So hi everyone, welcome back to the Helix YouTube channel. Today's video is going to be a speed run through analyzing gene expression data and actually retrieving the gene expression data sheet and process and basically cleaning it up so you can do machine learning and more customized statistical analysis with it. So just as a quick refresher, the data we get is from the Gene Expression Omnibus, which is hosted by the National Center for Biotechnology Institute, something like that. And yeah, so I'm going to share my screen. So the first thing you want to do is you will be navigating to Geo2R website. So the Geo website. So NCBI Gene Expression Omnibus. So click here, Geo, first result. And over here on the right side is where you can actually search your data set. So just for the sake of this tutorial, I'm going to use Parkinson's. So let's say we're looking at an experiment using Parkinson's disease. Quite a lot of results. And let's say our specific goal is to find biomarkers to detect Parkinson's in the blood. So I'm cheating because I've already done written a paper about this specific topic, but just for the sake of the video. Let's see. Okay, there are a lot of cool ones here. Actually, maybe I should go back and someday. So the exact ID code, which is GSE6613, I'm just going to skip right to it. Okay, so this data set is GSE6613, and it has gene expression data from blood of 50 patients with Parkinson's and 32 with neurodegenerative diseases that aren't Parkinson's, perhaps Alzheimer's, and 23 healthy controls, so people without any neurodegenerative diseases. So we're going to click Analyze with Geo2R. I'm going a little bit quickly. If you want to know how to do every single step, you should go to the Udemy course at helix.science/courses. I'm just going to speed through this because this is supposed to be a refresher video. Okay, so first, hold on. You need to define your disease groups first. On Geo2R, always assign your disease group first. It's really important. Otherwise, the computer program will give you the opposite result. It'll give you a negative number when you should have a positive number, and a positive number when you should have a negative number. So yeah, okay, so I'm selecting all the whole blood samples. Feel free to slow down the video if I'm going too fast. Sorry, I should say control. Don't know why I typed in blood. Control. Okay. So I'm going to highlight only the healthy controls. We're not going to look at neurological disease controls in this example. So here we go. I'm clicking Analyze on Geo2R. And in a few moments, it can take a few minutes if you have a lot of samples to process. In my experience, if you try to do any more than like 300 samples at a time, Geo2R will just crash or take so long. Hopefully this doesn't take too long. While that's running, I can quickly, okay, never mind. It's already done. So here are some really cool graphs that Geo2R was updated in about November to have. Actually, it's kind of funny because when I was recording my video for the gene expression course on Udemy, that was actually the exact same time when they changed Geo2R. So by the time I had published my course, it was no longer the most recent, which is the reason for this video, kind of like an update. Anyway, this table is a table with the results from the differential expression analysis, basically comparing the gene expression values for each gene in the micro experiment and comparing to how much is expressed in in Parkinson's patients versus control patients. So for example, the itch gene, the itchy E3 ubiquitin protein ligase, it is more expressed in Parkinson's patients than in control patients. And you can kind of see the difference in the chart. In this column is the p-value. P-value is a statistical measure. If it's less than 0.01, that usually means that it's good. The gene is differentially expressed. I'm not going to go into all the statistics, but just know that generally this number should be less than 0.05 or 0.01. Anyway, so if you just click on any of these rows, you'll get the gene expression comparison chart. Pretty cool. Okay, so but the thing is, this is all really awesome. They did a great job programming this tool for us. You don't need to, it's like a few just clicks, right? It's really easy. But if you want to do actual in-depth analysis, you'll need to work with the data itself. So one thing is that you have this process data, right, of each gene, but you don't actually know the stuff behind it. So let's say if I wanted to ask, could we use itch as a biomarker for Parkinson's? How accurate would it be? You can't tell from this graph. You can't say like, oh, it'll be 80% accurate. There's no way to analyze this. Well, I mean, I guess okay, not really, but there's no way to like just take this output and determine how good a biomarker would be. So what we need to do is we need to actually get the raw data from the experiment. So GO2R isn't just getting this result out of nowhere, this awesome table, it's processing some data, right? So we need to get the base raw data from which all this math and calculations and statistics came out of. So let's go back to GSE 6613 dataset entry page. Down here is really important. As you can see, it says raw data provided a supplementary file. So if you want to get the actual data, you should click on series matrix files. It'll take you to another web page, and from here, download the txt.gz file. It's a little bit, if you're on Windows, you might have to download a software called 7-zip, I think, or GunZip, which can be a little tough. So just be aware of that. So now I'm gonna pause my screen share so I could share the rest of my screen for the next step. New share. Just one moment. I want to show all my files. Okay, currently I'm unzipping the file, and it should be coming up as a text file. Great. Okay, now I can share that. So at this time, you're seeing a nice txt file. If you're on Mac, it'll open in TextEdit usually, and if you're on Windows, it'll open in Notepad. And this is a huge file usually that has all the raw expression values from the micro experiment for each of the genes and each of the samples, or microRNAs if you're using microRNAs, etc. And it is a lot of data. It's really awesome, but it's harder to work with. So that's why GO2R does a great job of getting rid of all that. But eventually you'll need to learn how to wrangle the raw data. So the first thing is that we can get rid of all this like supplementary information, like when it was made public, because that's not going to be very relevant when if we're just trying to look at gene expression differences and build a machine learning model. So let's just delete that. We can also delete the sample submission date, sample last update, sample type. These are all the same, pointless information. Sample channel count, pointless. This is all pointless. So essentially, it's going to be different for every single data set depending on what kind of information the scientists who published it put in. But for the most part, you just need to be careful about what you delete. For example, all this we don't need. Sample ID is sometimes useful, but we don't really need it in this example. So I'm going to delete all that. We do want to keep the sample title because we do need to be able to match each of these values with what sample it's coming from, right? We can't just be working with a data set with no labels at all. So we'll keep that. But as for the rest of this stuff, most of it is pointless. So I don't think we need the GeoExpress. We don't really need this. Sample characteristics is probably helpful. It should be the same as that, actually. So let me just delete that. It's perfect. Sample molecule, yeah, delete that. All this is the methodology. It could be important, but you don't want it in your data for analysis. Okay, so let me just try to speed things up a little bit. Feel free to skip this part in the video. But yeah, okay, so this should be it. Series matrix table begin. Delete. And at this point, see, we have saved the labels of the data. So whether it's Parkinson's or control, we've saved the ID. So the sample's ID label, each sample is a unique ID label. And here is the raw data. Each column of the data is a sample, like a patient, and each row is a gene. So for example, 117AT, I don't know at the top of my head which gene it corresponds to, but it's a probe on the microarray, and it corresponds to a gene. These numbers are unitless. Okay, so at this point, I'm going to save. So just do Command S usually, or File S if you're on Mac, File Save if you're on Mac. And yeah, so we've done this part, and the next part is to upload it into Google Sheets. So let me just share my Google again. Oh, I need to enter my password. Don't hack me, please. Okay, so Oh, I'm not actually sharing my script tab, am I? Okay. New share, Google Chrome. Okay. So I've gone to Google Sheet. Is this working? Okay, yeah, it is. I've gone to Google Sheets. I made a new spreadsheet. I'm going to call this GSE 6613 raw data. And now we're going to import the data from the text file. So I'm going to go to File, Import, Upload, select file from your device.